this exercise, we'll be practicing finding probabilities under normal curves. The information comes from a survey in some country where 28% of adults do not own a cell phone. Let's suppose that we have a simple random sample of 200 adults. The first question we want to address is whether this sampling distribution is going to be normal or not. And we need to think about three different issues when we're doing this. So the first is that the data need to come from a simple random sample. And we have that in our problem right here. We have that it's a simple random sample. The next thing to check is that the sample observations need to be independent. In reality, we don't have this. We're not sampling with replacement. But it turns out we're okay with this requirement as long as our sample size, which was 200 in this case, is less than 5% of the total population of adults. And that's a reasonable assumption in this case. So we can assume that there are at least 4,000 adults in this country that we're examining here. And then the last criteria is that we need to have n times p be at least 10, which it is in this case, and n times p times 1 minus p also be at least 10, which it also is. So having met these three criteria, yes, we can say that the sampling distribution of p hat is going to be approximately normal. And then we know something about the mean and the standard deviation of that distribution. So if we've met those criteria, we know the shape's going to be approximately normal, and we know that the mean for the distribution here will be 0.28, as was given in the problem statement here. That's our p. So that's going to be our mean for the sampling distribution of p hat. And then we also know that the standard error for that distribution is going to be 0.28 times 1 minus 0.28 divided by 200. Take the square root of that whole thing, which gives us 0.032. So that's going to be the standard error for our sampling distribution. And the graph that we're looking at here is the distribution of p hat, which is the sample proportion who do not own a cell phone. So we're looking at how does that sample proportion behave. Now, the first question that we're going to address is this one. What's the probability that in a random sample of 200 adults, more than 30% do not own a cell phone? First, let's look at that on our graph. So we can put our 30% right here. And we want this area, this probability, more than 30% do not own a cell phone. You can use some notation for that if you like. I'm going to match the way we see it in GeoGebra. So we're looking at the sample proportion, p hat being greater than 30%. And to find that, we'll go to GeoGebra. We are going to set it up with the appropriate mean, which here is 0.28, and the standard error that we found, which was 0.032. So there's our distribution, and we are wanting an area that's greater than 0.3, like this. So there matches our graph here. We're looking at the area above 0.3, and that area, or probability, is 0.2, let's go to 4 decimals, so 0.2660, or about 26%. If we're going to interpret this, what it means is that if we had 100 random samples of 200 adults, then we would expect that about 27 of these samples would result in more than 30% of those in the sample not owning a cell phone. Let's try another one. So this question says, what's the probability that in a random sample of 200 adults between 25% and 30% do not own a cell phone? We're still talking about the same sampling distribution. We decided it was normal because it met those criteria. We have the mean for the distribution of sample means. Remember that this is the same as the population proportion, so that's 0.28. This is our distribution of p hat, the sample proportion who don't own a cell phone. And then the standard error for that distribution, which we found above, was 0.032. So in this case, the probability that we're trying to find is the probability that our sample proportion p hat is between 0.25 and 0.3. Over in GeoGebra, we're looking for this in-between area. We want it between 0.25 and 0.3. Notice we've still got that mean and the standard error listed here. So that area, that probability, is 0.5598 if we round it to 4 again. So about 56%. Okay, one more. This question says, would it be unusual, so we're asking a probability question, for a random sample of 200 adults in this particular country to result in 50 or fewer who do not own a cell phone, and why is that? Notice that it didn't have to explicitly say that we're talking about a sample proportion. They actually gave us a count, but we're asking a probability question about how that behaves, and we're talking about 50 out of the 200 in the sample, or 0.25. So we're asking whether it would be weird to see 0.25 or fewer who do not own a cell phone. We are talking about the distribution of p hat. So same graph still. This is the sample proportion who do not own a cell phone. Notice that it's centered at 0.28, which is the center of our distribution for the sample proportion. We know the standard error. That's 0.032. And then we're asking a probability question. Just realized I didn't color it in on the one above. I'll do it in a second. Okay. We're asking a probability question about it being 50 or fewer, which was 0.25 or fewer. So right here. It's really nice that GeoGebra does the picture for you, but if you'll sketch it first, you'll be more successful. So I didn't do it on this one. It was between 0.25 and 0.3. Something like that. Alright, and on this one we're looking for fewer, so we're looking at below 0.25. And then if we wanted to write it in probability notation, we're looking for the probability that p hat, or sample proportion, is less than or equal to 0.25. And then in GeoGebra, to find the areas, got the right mean, right standard deviation, we're looking for this lower tail. We want it less than 0.25. There we go. So that area, that probability, if we round it to 4 decimal places, would be 0.1743. So there's the 3 probabilities that we found. To answer this last question, we wanted to know, was it unusual? I would say with 17%, that's not very unusual. Okay, I want you to notice something before we move on from this problem. Notice that we had a probability of about 0.27, we had a probability of about 0.56, and here we have a probability of about 0.17. Now when I add all of those up, they add up to 1. Why? I hope you thought about it for just a second. If we look at our curve and kind of put all these together, we had this graph, right, centered at 0.28. So the first one, we found the area above 0.3, up here. On the second one, we found the area between 0.25 and 0.3, this area here. And then the last one we did, we found the area below 0.25. There you go. So our total area under the curve should sum to 1, and that's what we just verified.